Some of the most incredible technologies ever developed by humanity were designed for space travel. Two of these remarkable innovations are the Voyager spacecrafts, which continue to amaze us even after decades of non-stop discovery. Although both spacecrafts are on separate missions, Voyager 1 has just detected a massive object hurling through space. What was unexpectedly found traveling across space near the Voyager spacecrafts? How will this affect Voyager's future space exploration, and why does this newest discovery have scientists scrambling for answers? Let's find out. As part of the Voyager program, NASA launched Voyager 1 on September 5, 1977, intending to study the outer solar system and the interstellar region beyond the Sun's heliosphere. Voyager 1, launched 16 days after its twin Voyager 2, entered interstellar space as the first artificial object to do so. Its purpose is NASA's mission to explore the furthest reaches of space and the deeper levels of our solar system. Voyager 1 has been traveling for more than 45 years and is now the object created by humans that is the farthest distance from the planet, estimated to be 14 billion miles away. Despite this, light from the Voyager 1 spacecraft only needs 22 hours, 2 minutes, and 54 seconds to reach Earth, so we are still able to collect new data from the spacecraft despite its far reach into the cosmos. Voyager 1 was launched after Voyager 2 because of a quicker path. It left the asteroid belt before its twin on December 15, 1977. In April 1978, while it was around 165 million miles (265 million kilometers) from the planet, it started its Jovian imaging mission. Jupiter's atmosphere seemed more tumultuous in images returned than during the Pioneer flybys from prior years. Voyager 1 started taking pictures on January 30, 1979, and continued doing so every 96 seconds for 100 hours. This resulted in a color time-lapse video that showed 10 revolutions of Jupiter. The spacecraft entered the Jovian moon system on February 10, 1979, and in early March, it found a narrow ring around Jupiter that we had never seen before. This discovery alone was a major milestone for the NASA crew back on Earth. Then, on March 5, 1979, Voyager 1 made its closest approach to Jupiter at about 174,000 miles (280,000 kilometers). Subsequently, it passed by several of Jupiter's moons, including Amalthea, Io, Europa, Ganymede, and Callisto, in that order, sending back stunning images of their landscapes and revealing entirely new worlds to planetary scientists. One of the most intriguing discoveries was made about the planetary body Io, where photos revealed a strange yellow, orange, and brown globe with at least 8 active volcanoes spouting material into space, making it one of the most geologically active planets in the solar system. The existence of active volcanoes raised the possibility that the oxygen and sulfur in Jovian space may be due to sulfur dioxide-rich volcanic plumes from Io. Thebe and Metis, 2 more moons, were found by the spacecraft. Voyager 1 made its first course adjustment after its encounter with Jupiter on April 9, 1979, in order to be ready for its rendezvous with Saturn. On October 10, 1979, a second adjustment ensured the spacecraft wouldn't collide with Saturn's moon Titan. In November 1979, it made a flyby of the Saturn system, which was just as stunning as the first time. 5 new moons were discovered by Voyager 1, along with a ring system with thousands of bands, wedge-shaped transient clouds of minute particles in the B ring that were dubbed spokes, a new ring called the G ring, and shepherding satellites on either side of the F ring that maintain the ring's sharp edges. The spacecraft captured images of Titan, Mimas, Enceladus, Tessis, Dione, and Rhea during its approach to Saturn. The incoming data suggested that all the moons were mainly water ice. Titan was the target that Voyager 1 passed by on November 12, 1979, at around 2,500 miles (4,000 kilometers). Images revealed a dense atmosphere entirely obscuring the surface. The probe discovered that nitrogen comprised about 90% of the Moon's atmosphere. At the surface, there were 1.6 atmospheres of pressure and a temperature of minus 292.2 degrees Fahrenheit minus 180 degrees Celsius. According to atmospheric data, Titan may be the first planet in the solar system other than Earth where liquid may exist on the surface. Nitrogen, methane, and more complex hydrocarbons were also found, suggesting that primordial chemical processes would be conceivable on Titan. At 23:46 on November 12, 1980, Voyager 1 made its closest approach to Saturn at around 782,290 miles. After the near collision with Saturn, the spacecraft continued its mission, sending back invaluable data and images that continue to contribute to our understanding of the outer solar system and beyond. Voyager 1 set out on a course to leave the solar system at 523 million kilometers per year, 35 degrees to the north of the ecliptic plane, and roughly in the direction of the Sun's motion with respect to nearby stars. The spacecraft was not pointed towards Uranus and Neptune due to the unique need for the flyby of Titan. The first portrait of the solar system as viewed from outside was created on February 14, 1990, when Voyager 1's cameras were oriented backward and took roughly 60 pictures of the Sun and planets. The photos were captured at a distance of 43.7 billion miles, 6 billion kilometers from the Sun. The pale blue dot image, widely famous by Cornell University professor and Voyager scientific team member Carl Sagan, 1934 to 1996, was created from a mosaic of those pictures. The picture has also been referred to as the Solar System Family Portrait, despite the absence of Mercury and Mars. Only Mars's dark side was visible to the cameras because Mercury and Mars were on the same side of the Sun and couldn't be seen. The two Voyager spacecraft took 67,000 photos before taking the last batch. Their cameras were switched off to save power and memory for the intergalactic voyage. After the last planetary encounter concluded in 1989, Voyager 1 and 2 missions were declared part of the Voyager Interstellar Mission, VIM, formally launched on January 1, 1990. The new mission aims to take NASA's investigation of the solar system beyond the region around the outer planets and even farther to the furthest points of the Sun's sphere of influence. Data collection on the boundary between the heliosphere, the area of space dominated by the magnetic field and solar field of the Sun, and the interstellar medium is one of the specific objectives. When Voyager 1 passed Pioneer 10 on February 17, 1998, at a distance of 69 Australian dollars and 40 cents from the Sun, it took the title of the most distant human-made object in existence. On December 16, 2004. The scientist working on Voyager 1 stated that at 94 Australian dollars, Voyager 1 had recorded high magnetic field intensity readings, suggesting that it had hit the termination shock and was now in the alio sheath. On August 25, 2012, the spacecraft finally left the heliosphere and started the first spacecraft ever to measure the interstellar environment. According to NASA, Voyager 1 detected significant changes in the environment, including an increase in charged particles and cosmic rays in June 2012. As a result, Voyager 1 became the first spacecraft to enter interstellar space at a distance of 121 astronomical units from the Sun. This signaled the inner boundary of the heliosphere. It was exceedingly fortunate that Voyager 1 did not rely on solar energy at this stage since sunlight took more than 16 hours to reach Voyager 1. Voyager 1 was moving more than 10 miles per second away from the Sun. At this distance, Voyager 1 will take more than 73,000 years to travel at present speeds to Proxima Centauri, the nearest star to the Sun at a distance of 4.2 light-years. However, Voyager 1 is not traveling in the direction of Proxima Centauri. Instead, it is traveling in a different direction, making a straight line to the constellation. According to a NASA study, mission controllers at Voyager 1 reportedly detected significant collisions with high-energy particles in 2012. These particles were once believed to be cosmic rays from supernova explosions far beyond the solar system. Along with this rise in high-energy particles, there was a sharp decline in low-energy particles from the Sun. According to researchers at Johns Hopkins University, these two events were sufficient to confirm that Voyager 1 had totally left the heliosphere and was now in interstellar space. The magnetic characteristics of this location looked to be different from what had been predicted. However, scientists soon saw something unexpected in the data. Dr. Ed Stone, the project scientist for the Voyager spacecraft at the California Institute of Technology, said in a statement, "Voyager has discovered a new region of the heliosphere which we had not realized was there. Apparently, we're still inside, but the magnetic field is now connected to the outside, so it's like a highway letting particles in and out. However, the magnetic field is now a part of the outside world, so it acts like a highway that allows particles to enter and exit. This unusual magnetic field phenomenon revealed that the area was 10 times stronger than experts first thought. It was anticipated to be the final obstacle to be cleared before Voyager 1 had left the solar system and entered interstellar space. Since Voyager 1 entered interstellar space in 2012, scientists have been eagerly awaiting feedback from the spacecraft, as no spacecraft has ventured that far into the universe. Voyager 1 sent data back to Earth that stunned scientists. It reported that the darkness of space had changed significantly since it entered the new region. As a result, scientists now have more questions than answers. Voyager 1 started reporting strange activity just as the scientific world was about to declare interstellar space to be a calm and quiet place. The spacecraft reported a plasma wave signal, implying a distant object was generating low-level plasma waves. Scientists initially thought this object might have been left over from the solar system, but after further investigation, they realized that the plasma wave was very different from anything that had been detected in the past. The signal appeared to be coming from a massive object of unknown origin, suggesting that Voyager 1 had encountered an enormous structure in interstellar space. The discovery surprised scientists because they had not expected to find such a large object so far from the solar system. In addition to the unexpected plasma wave signal, Voyager 1 has also detected a significant increase in cosmic rays since entering interstellar space. These rays are high-energy particles that travel through space at nearly the speed of light, and their presence indicates that Voyager 1 is encountering a region of space that is more turbulent than previously thought. The detection of cosmic rays suggests that Voyager 1 is traveling through a region of space with more activity than scientists initially believed. This has led to speculation that Voyager 1 may have encountered a massive structure or object that is causing the increase in cosmic rays and the plasma wave signal. Scientists are now working to analyze the data from Voyager 1 and determine the nature of the mysterious object or structure that the spacecraft has encountered. This unexpected discovery has prompted scientists to rethink their understanding of interstellar space and the objects that may exist within it. The Voyager spacecraft continue to provide invaluable data and insights into the outer reaches of our solar system and beyond, and their discoveries will likely continue to shape our understanding of the universe for many years.